Hello guys, welcome to today's class where we'll be looking at how we can solve examples using the combination method. Now, in the last class we introduced the combination method and then everything it entails. In today's class we'll be looking at how we can actually use it to determine our binomial coefficients. That is, to actually expand a question of binomial theorem. Now, we have this question here, example 1 here, we are asked to using combination method, expand x plus 3 all raised to power 3 completely, x plus 3 all cubed completely. Now, you realize that this was the first example we used when we did our Pascal triangle. In this case, we can actually use our combination method as well. Remember we said in the last class that the combination method is like an overall method that we use to solve binomial theorem. So the combination method is like an overall method we use to solve every type of question under binomial theorem. So we can actually use this to solve, and let's see how correct this will give us. Now, we have a question here, we have x plus 3 all raised to power 3. Now, I said the difference between Pascal triangle and combination method is that in the Pascal triangle, we are already given our coefficients from the Pascal triangle, but in this case, we'll be deriving our coefficients ourselves through our knowledge of combination. Now, we have x plus 3 all raised to power 3. From combination, the very first thing you do to get our coefficients, for the first value, we take it as as 3 combination 0, and then you take the total value, combination 0, then you take the x raised to the total value, that is the first value here, raised to the total power of 3, which we already know, and then the second value, which is 3, raised to the power of 0. The only difference here is the coefficients. And then how do we make these coefficients? How do we combine these coefficients? We take the total power, which is 3 in this case, then we have our 0, which is the second value. So we have 3 combination, which is where we start from. We start from 0, we now start moving on 0, 1. We start from 3 combination 0, the next one will be 3 combination 1, next one will be 3 combination 2, like that, until we reach our total power of 3. So we stop at 3 combination 3. So for this first one, we have 3 combination 0, we have x cubed times 3 raised to power 0. Then, this is the first term. We can move on. Moving on, we have plus, since the first one was 3 combination 0, the next one now will be 3 combination 1. From 0 we move to 1. Now the same thing happens here. Our 3 reduces to 2, while the power of 3 here increases from 0 to 1. Moving on, we have 3 combination 2 now. We have x raised to power 1. So our power of x reduces from 2 to 1, while our power of 3 increases from 1 to 2. Plus the last one, which will now be 3 combination 3. Our x reduces from power 1 to power 0, while our 3 increases from power 2 to power 3. Now we are here. We can now simplify. We know from combination, we know 3 combination 0. Because we have done combination, our idea of combination is very complete. We know how to break this down into factorial. You can easily say 3 combination 0 here will give us a value of 1 times x cubed times 1. When the 3 raised to power 0 is 1, plus, looking at the next one, we have 3 combination 1, which will give us a value of 3. Then we have x squared times 3. Moving on, we have 3 combination 2, giving us 3. And then we have x squared, 3 squared giving us 9, plus the final one, which is 3 combination 3. 3 combination 3 is giving us 1 again, which is also 1, where we have x times 9. So these are the 4 terms. If you look at this thing very well, you realize that each of the coefficients, we have 1, 3, 3, 1. You can see that it goes along with the coefficients derived from the Pascal triangle. Remember that for the power 3, we have 1, 3, 3, 1 as our binomial coefficient. So you realize that this is just a method of deriving those coefficients ourselves without using the Pascal triangle. Now in this case, it look like it might seem as though this method will be wasting more time than the Pascal triangle, as you will just be needing to derive the coefficient yourself. But in cases where you have your fraction, like in the next examples I will be taking, you realize why this method is very, very important in the study of binomial theorem. Now, solving this, moving forward, we have x cubed. 3 times 3 here gives me 9x squared. 3 times 9 giving me 27x squared plus 9. Okay, 3 raised by 3 rather. 3 raised by 3 here should give me 27 instead of 9. So the same change should occur here. So this becomes my final answer. Okay guys, so this is where we'll call it a day. In the next class, we'll be looking at another example on how you can actually apply this combination method to solving questions. See you next class.